Cool. So we'll spend like 40 to 45 minutes on coding problem.
Mm-hmm.
Uh, then last 10, 15 minutes we will keep it for the feedback.
Okay. Uh, do you... Okay, no worries. Go ahead.
Oh yeah, please say.
I just want to like share that I am going to interview for Microsoft for for I guess it's T1 level. I just wanted to
Okay.
yeah, I just want to let you know that I'm preparing for that.
Okay. Sure. Uh, yeah, I never worked at Microsoft, so I'm not aware of like the format exactly, but
Hmm.
I do feel like they would have a typical coding interview.
Okay. Okay, should I just go ahead and start with the question?
Yeah, yeah. So basically, you have array of routes. So each route is
Okay.
nothing but number of like a series of stops that a bus takes,
Okay.
and that bus will keep on repeating in that route in circles.
Hmm.
And along with these routes, you have two things: a start and a stop. So basically, you have to tell like what are the minimum number of buses you need to take to go from source to the target. And if there is no way you can go from source to target, you should return
Hmm.
-1.
Okay. Uh, let's see. So basically, source here is one in the example first,
Mm-hmm.
and the target is six. So this is the bus number one, right?
Mm-hmm.
And
Yeah.
and it goes to these stops. You can say one, two, and seven.
Mm-hmm.
And
Mm-hmm.
there is another bus that is like three, six, and seven. So basically, we have to take like uh, um, so the question is basically the number of buses, right? So here,
Right.
uh, okay, so from first I can take seven, right?
Mm-hmm.
And then seven can go to three,
Mm-hmm.
right? And then three goes to six. So I guess this should be like two number of buses that I have to take, correct?
Okay. Right.
Uh, so what I'm thinking is basically it can be represent as like a um, graph problem.
Okay.
So I can what I can do is basically convert these arrays. Sorry, am I audible? I'm
Mm-hmm.
just getting this
Yes,
error.
you are.
Okay, no worries.
No, no, you're audible.
Okay, this is to take the first bus to this. Okay, no worries. So and then I have these routes. So for example, second I can go. So um, okay, so this okay, this is 12. So I'll take this bus as this is the source, so 15, and it has 4 and 5. So okay, but 4 and 5 is connected to like nothing, like no other buses at
Mm-hmm.
the stop. So that's why I cannot reach to this particular source that is 12, right?
Mm-hmm.
Okay, so what I'm thinking right now is um basically creating like a graph from this. So in my graph, it will be basically, so I'm just taking the first example. So I'll go through the like arrays of array. So one that is connected to two, right? And two is
Mm-hmm.
connected to seven, right?
Mm-hmm.
And then I'll traverse through like the whole array. And then there was three, so there will three will not already be present in the graph. So I'll just create like a three here,
Mm-hmm.
right?
Mm-hmm.
And then there is six, so six is already not present, so I'll just add that. And because seven is already present, so I'll just have a connection between six and seven. So that's what I'm thinking of building the graph. And once my graph is built, what I can do is I can just iterate over its like neighbors. Um,
Okay.
and what I'm doing is either we can do like a the depth first search or a breadth first search here. But
Mm-hmm.
our goal here is to like return the number of buses. So
So you are saying
uh,
that there is the nodes of the graph is nothing but the bus stop. Is that correct?
yeah. But again, in this type of in if I'm doing this,
Mm-hmm.
then the issue would be like how will I be counting the number of buses, right? Because like if six is connected to seven, if I like connect the six to basically seven,
Mm-hmm.
uh, what I'll do is I'll start with seven here, and I'll just go through like doing a DFS, sorry, doing a BFS.
Mm-hmm.
If I start, I'll go to its neighbors that will be like six and two, because
Mm-hmm.
and it will be like unidirectional because I guess I can go from like it will be directional bidirectional. But anyways, but if I go like from seven, if I start, it's just that there is no way of counting the buses.
Mm-hmm.
Uh, for me. Hmm. So this might have I might have to do think of something else here. Um, let me think. So let's say this has um so my buses will be zero. Um, source is one. Okay. So one can go to two and seven. Okay. Hmm. Uh, um, so three, six, but that should be like number of. So I might have to like make up an account of like number of buses as well.
Mm-hmm.
Uh, hmm. So if I take like a graph, no, like not checked. So if I do this, one comma two comma seven, but again I have the array index for that. Hmm. So I can just like from seven goes to one again, right? It does not go back to two, correct? If they're like routes
Mm-hmm.
given, so it's going from one to two to seven and going back to one, correct?
Right.
Hmm. Using routes bus is bus speak forever. For example, this is type zero bus travels in sequence forever. You will start at the bus stop source. You will stop initially. Okay. So from seven, I'm just trying to represent if I like basically if I represent this in like a 2D array. Um,
Mm-hmm.
so I'll take this. Okay, and then this and this. So let's say if I have like 7 and 12, um, if I have this, so 1, 2, and 7. Um, but again, it can be anywhere. So 2D not work here. Hmm. Mm. So if I take, so if I create a graph, so basically 0, comma 0, comma 0, 0, input 0, 1, what happened? Status 1, and then 1, 2. Hmm. So again, like I'm thinking right now in because I can have like a an object where I can represent like the key as in buses. But again, in this case, I'm just thinking of I cannot traverse here. So if I have to traverse, there has to be like some of kind of graph connection. I'm just thinking of can I pass like the number of buses that I am in? I'm just connecting. So if I found this, uh, I have to um, like I'm just keeping an account of like it's in the same bus or the different bus. Mm, so here I'll start with the source. Source is one, and there can be multiple sources as well here, or can there only be one source and one target? How will that be?
There will be just one source and one target.
Okay, so mhm. Hmm. So if so basically will have
Mhm.
one will have I can go to two. Um, then from two I can go to seven. From seven I can go to one again. Uh,
Mhm.
for other one, what I can do is I can have like three. Three can go to six. Okay, now to six. Um, my six from six I can go to seven, and from seven that is already there, so I can go to three. So seven can go to three. So and then three can go to six. Uh, okay. So here, if I start from the source that is one, one goes to two, it visits two, then two goes to seven, seven goes to so there it can go to one that is already visited right now, and then it will then go to six, and then six will go to three. Sorry, three. Three will go to six, and six is our target. But again, here I should be. Mm, basically, I can do something like one. So basically, a bus number, comma one. Um, 1 comma 1, and but 3 is basically 2, right? And the 6 is 2 as well, and the 7 is 2. But anyway, so like if I reach the target, if I have the target, I will just return the number. Okay, yeah. So sorry, I got like a little bit stuck over there. So what I was thinking is basically like again creating a graph out of it. Now, instead of just the node, what I'll be thinking of is creating basically uh, keeping an counter of which bus is it. So basically, if I take this example 1 to 7, like the first one, so the one will go to second, right? The second will go to
Mhm.
seven. Seven will, so as one is already visited, it will visit like, oh, but no worries, it will anyways visit uh, um, the children's, right? So if I start from seven, it will go to one, so second and seven,
Mhm.
and then it will go to the second child, that is three, and three will go to six, and six is our source, and it will just return the bus number. Um, that should be uh, that should give us the transfer and the bus number. Uh,
So what is like
this
one? Okay, so you are having a mapping of like a bus stop to what buses goes through that bus stop.
Yeah, I'm just like I'm thinking of so I have like this arrays, right? So I'm just thinking of how
Mm-hmm.
will I be taking an account of the number of buses, right? So if I start from one stop and I go to the other stop, so basically if I don't count one here, basically like if I don't keep an account of the number of buses, and I will just create this graph. It will just visit and it will tell us it is possible to go to this source destination, but it will not
Mm-hmm.
return us the buses it took, right?
Mm.
So this will be it will basically have the number of buses that uh, it will return us the answer, right?
Okay, so basically, uh, so if we take step by step, like when you will go through the array of routes and create this mapping first,
Mm-hmm. Mm-hmm.
and then you would add into the queue and iterate through it.
Yeah.
Okay, and what would be the complexity of that?
Uh, so again, the complexity of that would be like worst case would be like going through every element. So uh, so all the routes that I have. So uh, in the worst case, if there is like no mm, there is the target is not present, then I have to like traverse the whole thing. But if I'm considering that there are R routes, then O of R basically, and it is traversing
Okay.
like all the nodes. Uh, uh, should I like proceed like doing code, or we can discuss on it more? What do you think about it?
So can you walk me through like first example? Okay, you already
Okay.
did that. Okay.
Y- Yeah. So basically, my source start is seven, right? So I'll go to
One,
seven.
right?
Oh, sorry, my bad. My start is one. So
Mm-hmm.
basically, I'll traverse with one. I'll have like a something as visited set that I'll be carrying for the nodes that I've already visited,
Mm-hmm.
right?
Mm-hmm.
So I'll put that uh, in the queue. Uh, then I'll traverse that. I'll see if I'll traverse to the children's, like the nodes, the neighbors of it, and so the next I'll just maintain a queue here. So basically one, and then it will come to the children of it, that is two, right? And it will come to seven. So so I'll go to the node and then I'll traverse to the neighbors of it. So two and two will be I'll be going to seven because seven is like neighbor of two. Then when I come to seven, it will visit one and it should be present in this visited node already. So what I'll do is I'll traverse with the other node, that will be three, right? Then three,
Mm-hmm.
from three it will go to six. Uh, and then six is basically our source, like the target. target is 6. So and I can like just return the number here, like the counter that we are keeping.
Mm-hmm.
So how does that sound? And obviously, like this is like one case that we are thinking of. Uh, Another one, I'll just like at the end, I can just have a if I don't find the source target and if I'm not like exiting early, I'll just like return that. I'll return at the end that it's a -1. Basically, the node is not present. Um, so, does this approach sounds good, or you have like a better approach in mind, or if I'm going wrong anywhere?
No, I think we can code.
Okay, so um, okay, so function search route. Function search route. It will just take routes. Okay, and then what will happen is under this. So I'll be creating a graph out of it, and so I'm using like a helper function build graph. What it will do is um, now what I need here is basically for let zero I is less than routes dot length I plus plus. I'll be creating a graph here, and at the end I'll be just returning the graph. So now I'll have let so I'll be getting an array in that, right? So let I'll just use a of I, and then for that j equals to 0, j is less than 10, j plus plus. So if my basically my temp of j is in graph. If it's not in the graph, then what I'll do is I'll just create that and then I'll push it. So if I'm at 2, 2 will push the second one. So it should be 10 dot push temp of I plus 1. But again, this I have to handle here if I plus 1 is equals to temp dot length. Where else this? push this. Actually, I'll be pushing this and comma I plus 1. So if it's like the last element, what I'll be doing is copy this. If it's the last element, I'll still be creating. So this I can do here. Sorry. Yeah. So temp of 0 basically. If I'm like the last position, I'll be pushing it to 1 again. So after doing this should build our graph. Okay, then I'll just have my so for that I equals to 0, I is less than root dot length I plus plus for let j equals to 0, j is less than of 0 dot length and j plus plus. Okay. So basically, if my routes of I comma j is equals to I will be having like a start and end. So start and an end. So if it's equals to start, right? So then I have to do my traverse basically. So I'm just so I'll be traversing and that should return me this. So I will just do a traverse. I'll call the traverse here. And what I'll do is I'll give routes of I, comma j. Then I'll provide the graph. I also have to have like a visited. So I'll be just creating a visited set here. Okay. So I'll come back to this. I'll start writing the function first. So function, just take this here. So this will be like my node, right? So I can do like if visited dot has the node, I'll just return it. If otherwise, I'll just visited dot add the node. I'm just handling it here. Oh no. The node should be okay. Let's see. Let q equals to node. Okay. While my q dot length is greater than 0. So let my this Um, so what I'm thinking is, so there will be like a stop and the bus here. What I'll be doing is q dot um, shift, and then for let uh, neighbors neighbors so I'm doing this neighbors of stop. So here what I'll be getting is I have a graph, right? Graph of stop. So neighbor of stop. If so here I can check not in visited if it's already not in visited. Um, then I want to push it q dot uh, push the um, so if this is neighbors, so this is stop. Okay, I'll push the neighbor here, right? Um, so here I have to check if my so neighbors here drop or stop will be again this. So neighbors here stop. Okay. So this should again be like I can destructures to and stop and pass here, and then if and stop isn't visited, I'll be pushing the but I have to push the whole thing, so I have to push this here, and if my end stop is equals to end, I'll just return the bus here.
Mm-hmm.
Okay. Um, and so I'm returning bus. If I'm not returning bus at the end, I'll just return like -1. If I like all the iteration went, I went till all the things. So visited, I have to still add to the visited. So q dot push this, and then I can put this into visited dot add and stop basically. So yeah, so this will be expecting either a bus or whatever. So I can just return this, I guess. Uh, yeah, so what I'm doing is basically I'm starting with this function. I'm building the graph here. Then I'm starting from the root that is like the start root, right? And obviously here also, I guess I have to handle here -1. If I don't have the start position, they should handle that. Um, then I'll go to traverse and I'll be providing it with the, for example, one, right? Right. So this so one. It will go to Route of one, it will go to route. So one will be here. One will be in the queue, then it's then the shift. It will still be okay. So this has to be like a stop, and then I'm traversing. So stop of stop. So it will go to 201. So two is not
Mhm.
equals to end. So if it's not in the visited as well right now, so it will go in. It will push two in the queue. So I guess instead of this, I should be just pushing this and stop. It will go to two. So two will be here. It will go here. It still have length greater than zero. Two will be the stop. Then it will go to 271. So the end stop will be seven, and end bus will be one again. Then one seven is not the end. It will go seven is not in the visited as well. It will push in the queue. It will put in the visited. It will go to one, right? Uh, so one is already in visited, so it will go to the next of it. So that's three. Uh, Three it will put in the queue, and then the uh, so it will go to three children, and six actually is equals to end, and it should return the stop. So that gives us the bus number, like the buses, and it will just return here, and it will return two. If two was not six was not present, it should just press like go through all the list, and it will return -1, and this should return -1. So yeah, this is like my approach. What do you think about it? Oh, sorry. I have two parts, start and end as well. Actually, just end here for the reference. Uh, yeah. So I can try running it, or like, how do you want to go ahead now?
Yeah,
How
let's
does
try
this
running
work?
for first test case.
Okay, let's try doing that. Mm, so route is this, and then I have to call the with start and end.
Mhm.
Oh, source, with source and target. Uh, uh, so how can I run over here? For graph stop is for let and stop in graph of graph. Hmm. So it's returning -1. Why is that? Hmm.
Can you print graph once? What is the how you have built it?
Yeah. What's this? So my graph is this, and my key.
What is 2 comma 1 represent?
So it's basically
So basically, 1 to 7 is a no is a route, right? Which you are
yeah,
representing as a node. Okay.
yeah. So
And like it's mhm.
uh, but I did this. Um, Sorry about that. Um,
So if it's an adjacency list, right?
yeah, yeah, yeah.
The elements in adjacency list should also be routes, right?
Yes, yes. So that I'm trying is basically temp of oh, just a second. So from this, my temp is of G. Okay, not bad. So if temp dot length this, then temp of G is this, and then temp of G is this. So it should be okay now. Yeah. Uh, anyway, uh, so now I get to one, two is going to one again. Where is that? One is two. Um, J. Mm, yeah. So now it looks a little bit how I want it, but again, this is 7 and it's showing undefined. Why is that? Uh, so if it's like 7 is I guess at the end, it's yeah, it could be that. So if I plus 1 is temp dot length of 0, it should be j plus 1 is temp dot length then uh, 0. Is it? It's not running. Why is that? Hmm. So, can you run this code from your end? Because I'm finding it's not running. Like, is there an issue with the?
Yeah, I gave the same result. Uh, so it improved. Yeah. Now instead of undefined, it's showing something.
Oh, it is. Is it showing something for you?
Yeah, yeah, you can see right in the output. Uh, Instead of undefined comma 1, it's 1 comma 1.
It's not showing on my screen actually for some reason.
What is the can you scroll down the output window?
Yeah,
Let me
I'm trying
reset
to
the output
scrolling it.
side.
Okay, okay, sure.
Okay. Is the output reset for you?
No. Should I reset from my
Okay.
end?
Sure.
Oh, it's not. It's not. I'm not able to do anything here. Is it like locks us,
No
something like
worries.
that?
I don't know. Like, yeah, this is the first time I'm experiencing this. But yeah, anyway, like I'm like we're close to 45-minute mark.
Yeah.
So let's pause for a feedback. I think like you
Okay.
did well.
Mhm.
That you went through an example to make sure that you understood the problem, right?
Mhm.
You explain
Mhm.
about you also walk me through like what are your thought process about why this is the answer for first example.
Mhm.
Um, and then only like you went ahead and thought about solutioning it. And the
Mhm.
first statement was this would be modeled as a graph problem.
Mhm.
So I really like the way like you articulated the solution.
Mhm.
You not only just think in silos and try to keep thinking about like sharing the end result, but like when you were keeping me in a loop whenever during the process of coming for the solution. So that was a good
Mhm.
sign as an SD1. So I don't see
Mhm.
most of the SD1s doing that. They just try to they get a code out. But yeah,
Mhm.
on the communication front, you did a lot better than expected.
Okay.
Um, I think like yeah. So basically, um, next thing I liked about overall thing was like even when you were moving in the wrong direction, you were
Mhm.
calm and patient. Like you're still trying to get an input from my side,
Mhm.
which shows that you are receptive to feedback, which is one important aspect I look for like junior engineers. So
Mhm.
yeah, so you clarified like it's okay to assume that if there is only one source and one target,
Mhm.
which was a good question. Um, your approach was good.
Mhm.
Approach was on target. I think like
Mhm.
your time complexity analysis was off because like it's not just about the routes, right? You mentioned time complexity with respect to number of routes,
Mhm.
but the bus stops within a route are also important aspect of your approach, right? Because you are
Okay.
iterating through the stops also.
Mhm.
So yeah, that is one thing like which could have been done better.
Okay.
I think like another thing which was good is like you mentioned while writing the pseudocode that you would be using shared data structure to keep visited nodes,
Mhm.
which was again a good communication and right data structure choice.
Mhm.
And in coding, like I like the way you use a naming convention for methods.
Mhm.
Like they were like quite intuitive, and you wrote a modular code.
Mhm.
Again, like which is very rare when I interview for SD1s or even SD2s.
Mhm.
So overall, like I would have definitely been confident about giving a higher call based on this performance.
Mhm.
Um, yeah, I know like it's a close to working thing.
Mhm.
There might be some glitch in the implementation, but yeah, this was a good code at the end of it. And like even though like we took some time to come to the solution
Mhm.
approach, you took no
Mhm.
time. Relatively, you took less time to convert it into the working code. So yeah, you should be happy with this performance. If you would have been an interview I had taken, would
Mhm.
have been a high call.
Awesome. Thank you. So, can you discuss like I guess I still can you discuss a little bit about like how should I improve in like giving the complexities? Because this is something that I always do that I talk about the complexity because of, before coding. But again, like as
Mhm.
you mentioned that, and obviously after your input, I thought that it's I have to be better in giving the complexity. So how can I improve my performance? Like what points should I keep in mind, and like uh, what should I say in an interview so it should not be like a negative point for me?
I think like the timing is right. You should share the complexity before implementation only because if you don't do that, you might implement suboptimal problem which might not be acceptable,
Mhm.
and you
Mhm.
will lose interview time in that.
Mhm.
Uh, but yeah, so in terms of complexity, look at the input parameters, right?
Mm-hmm.
Though the source and target are constants, right? Variable thing, as you pointed out, is number of routes are, but at the same time, like how many bus stops within each route are, that was a one parameter which you missed totally while analyzing the complexity of your approach. So
Mm-hmm.
just try to spend some time about like what are the dimension or different aspects which will vary in the length in
Mm-hmm.
terms of input, and use
Mm-hmm.
those try to use those to find out the yeah, complexity.
Okay.
If it
So
would
that
have been a
should be.
single dimension array, it would have made sense. But I
Mm.
think like somehow in your mind it was like it's a one parameter, so I will be
Yeah.
like already using the size of it.
Yeah.
But
Okay.
yeah,
So then, like,
this is the case, but
here
most
the
of the
time
time it
complex.
won't be.
Sorry,
Mhm.
go ahead.
Yep. Yeah. So here the
So,
time complexity would be in terms of total number of nodes to build a graph, right? Total number of bus
okay.
stops across the routes.
Mm-hmm.
Uh, and then in order to go through, like you are going, like you are having multiple, so plus the number of nodes
Mm-hmm.
while traversing to BFS. So yeah, it's a combination of
Okay.
both of these parameters.
So routes and buses and okay, got it.
Right.
Uh,
Cool.
yeah, thanks. Okay. Mm-hmm.
Yeah. Do you have any other question for me?
Uh, no, I'm just like, have you ever like had a chance to like, but initially you said that you're not, you didn't like had a chance to work with Microsoft, right?
No, I never worked with Microsoft, but
Okay.
I did interviewed with them 3 years back.
Okay.
But I also realized that Microsoft hiring is very team specific. They don't have like generic format across teams or across orgs.
Mm-hmm. Mm-hmm.
So because like I have friends who have been giving interviews in Microsoft and are currently
Mm-hmm.
working in Microsoft. So
Mm-hmm.
their experiences varied because they applied in different orgs.
Okay.
So yeah, no generic format for Microsoft interviews. That's
Okay.
what my understanding when I gave interview.
Mm-hmm.
So yeah.
Got it. Awesome. Is there anything else for me?
Um, are you an university graduate applying for university higher role or
No,
you're
actually,
not?
I
In,
I was working at a company and I was reached
Mhm.
out by like a recruiter, basically a talent sourcer, and they told me that there is a hiring event in Microsoft and that's for like SD1 role. So that's why I got to know that it's like a SD1 role. But yeah, I'm just like I don't have like a specific level in mindset right now. I just want to like go and interview and
Okay.
because I guess yeah.
So basically, if you have industry experience, be prepared to talk about your current project in your last round. I don't think like initial rounds will discuss about that.
Mm-hmm.
If it is a hiring event, like mostly the last round would be with a hiring manager. They call
Mm-hmm.
internally AAA.
Okay.
Yeah, that guy would dwell upon your current project and your interest in technologies and yeah.
Okay. So basically, I talked to the recruiter and he said that right now it's for like everyone and mostly like backends. Till now,
Mhm.
whatever the internships and experience that I have is on front end, basically. Like mostly, I've all like if there are requirement, I have worked on the back end, but like mostly it's on front end focus. So will that be an issue in this process? Because I mean, obviously, I did my bachelor's and master's, and um, I have worked with like back end technologies, but I have not like have like field experience. So will that be a negative mark?
No, you haven't been lying. The only thing is like you shouldn't lie on a resume and get caught later. So if you have already clarified that, like if you
Mm-hmm.
receive, you already mentioned that you predominantly work in front end. I don't think that's an issue.
Okay.
And for one position, like it is expected that there would be some learning curve. So even
Okay.
during the onboarding part, there won't be much hiccups.
Okay. Okay. Got it. Uh, yeah. So I'm just like I have like done some preparations. I guess I got like maybe a couple of weeks. but I did just, it's interviews get nervous generally.
Yeah, yeah. So you can search on Google like bus routes or lead code. You will find this problem. Try to
Oh, okay.
submit code and debug it so that you get a hang
Yeah.
of implementation.
Yeah, yeah, I'll surely do that.
Cool. Awesome. All the best for your actual interviews. Bye
Thank you
bye.
so much. Thank you for your time. It was really, you've made me really comfortable. So it was like you were great as an interviewer. So thank you.
Yeah, my pleasure. Bye bye.
Yeah. Thank you. Bye bye.